Why does your brain fuel on either glucose or ketones, which are derived from fat? Why do the brains of babies need ketones for rapid building of their neural network? Can eating fats, such as C8, C10, help prevent or reverse brain aging? Do you have to go ketogenic to get the benefits? How can a ketogenic diet or supplements help mental health and mental illness? To answer these questions and other questions and explore the whole role ketones and fat play in your brain, my podcast guest this month is the leading world expert, Professor Stephen Cunnane, who heads the brain research team at Sherbrooke University in Sherbrooke, Quebec, Canada. Professor Stephen Cunnane also holds the clinical research chair in ketotherapeutics. So, Stephen, fantastic to have you on my podcast.
Thanks. Happy to be here.
So this is right, isn't it? Brain cells can either derive their energy from glucose or ketones.
Yes, that's true.
And early in life, and I don't know whether we know anything about fetal development, infancy, and so on, is a child's brain using more glucose, using more ketones? What do we know about the original development of the brain in relation to fuel?
So there are very few studies, but there are a couple. So the brain in the adult, just as a reference, is running about 95% on glucose, but that's always contingent on what we're eating. But let's say that the typical Western diet, if that exists, is our baseline. Then the brain of the adult is running almost exclusively on glucose, not quite. But the infant is in a different situation. So if you take 95% as the reference value for the glucose utilization by the adult brain, in the infant at birth, it's around 60% for glucose, 40% for ketones. So ketones are much more important at birth. And in the first few months, probably, we don't know exactly how long, but it declines obviously towards the ketone contribution declines as we move towards adolescence and adulthood. But there are two studies that have been done that show that they are absolutely essential, probably because the body is not able to obtain enough glucose or make enough glucose at birth. And ketones have that essential role at that in that period of life.
And is this, I mean, I have to ask, of course, where the ketones are being generated from, but also how much energy in a newborn baby is actually going towards brain development? And is there an advantage in having ketones for brain development as opposed to glucose? Or really, is it about just maximizing supply of both?
So two or three questions in there, but one of them is I think the amount of energy going to the brain in the newborn. It's around 70%. 70% of the whole infant energy requirements are going to the brain. So that's obviously it's about 2/3 to 3/4. The brain is very big in the infant compared to the rest of the body, but still that is a huge demand on the infant's energy resources, all going to fuel an organ which is really not very functional at birth. What were the other parts of that question again,
Well,
Patrick?
I mean, it's really interesting because, I remember with my conversations with Professor Michael Crawford that, humanity, I mean, that is the development of Homo sapiens, is so focused on brain development as opposed to body development. There are plenty of animals who develop very large bodies but very small brains. So,
Yeah.
here we're hearing that, 70% of all energy is going to power the brain. And, that's amazing. And you've already said that about 40% of that's from ketones. So where's the baby getting the ketones from? And why do we suppose that there is this, this sort of big focus in our evolution on ketone supply in the in these early months of life?
So the ketones, up until birth, they will be supplied primarily by the fat that the baby is accumulating, the fetus is accumulating before birth. After birth, the fat will still be contributing some, and this is a little conjectural because I don't think it's been extensively studied. But if the infant is breastfed, there are medium chain triglycerides in the breast milk fats that are ketogenic. So postnatally, and if breastfed, part of the ketones are coming from fat stores that the baby has accumulated, and part are coming from the medium chain triglycerides in the milk. Prenatally, they're all coming from the fat stores, and perhaps from, I don't think the mother is transferring medium chain triglycerides before birth to the fetus before birth. Um, and that's the unique thing about humans, apart from the big brain, is that our babies, if they're born at term, if they're born healthy, they've got 500 to 600 grams of fat, which is accumulated in the third trimester of pregnancy. So there's a big part of fetal development towards the end of pregnancy that involves deposition of fat on the fetus. And part of that, perhaps a lot of that, is being used to fuel the brain's energy requirements once the fetus, once the baby's born.
And I've heard outrageous numbers of connections that are being made between neurons. And, you might sort of give us a few facts there, but also, are ketones better for building brains, making connections?
Well, I don't know. I don't know what those numbers are about the number of connections and so on. Even those that claim to know, perhaps they're speculating to some extent. These are estimates. What's clear is that those connections are forming rapidly. They're also being pruned rapidly, because for effective communication, there's a whole bunch of dendrites that are reaching out to other neurons, but a lot of them are going to be cut back so that the circuits become more efficient. Otherwise, it would be mass confusion. So the growth and the pruning are both essential processes, but and they both contribute to normal brain development. I have no idea exactly what the rate of these processes is, but it is clearly an important part of healthy brain development. The role that ketones play in that is also speculative, as far as I know. The ketones are supplying, what's interesting is that ketones are doing two jobs in the brain. So they're helping, we talked about the energy requirement already, and their contribution probably 40% at birth, declining somewhat as you go through infancy. But they're also a key contributor to the architecture, to the wiring of the brain. And successful brain development is successful wiring, in the sense that the message has got to go down the copper wire between two cells, as it were, figuratively speaking. But the insulation has to develop so that signal gets to the destination we want it to. Initially, there's very little what's called myelination, insulation on those nerves at birth. Very few are hardwired at birth. So that myelin has to develop. And myelin contains various proteins, but it also contains lipids, that structure to make that insulation of the electric signal along the axon. Is also got an important lipid component. And ketones are a major contributor to the lipid structure of the myelin. So in that sense, it's clear that they're important for brain development, for successful brain development, apart from being a fuel to make sure the message is generated in one cell and is transmitted elsewhere. So they do have what's called an anabolic role, a building role, as well as a catabolic role, which means like a fuel.
And normally, I mean, there are two areas I'd like to explore. One is, there is a sort of concept. I even wrote a book called The Hybrid Diet, and the analogy is a car that can either run on electric, or petrol, either ketones or glucose. But it seems very clear that both are happening. So, you said with the baby, it's 40% ketones, 60% glucose. With your average, probably not very healthy adult, it might be 90% glucose. So, yeah, what happens, for example, in an adult? And I know you've done your research has been, on older adults with cognitive problems more so. But if you just supply the fuel, that makes ketones, which I really want to talk about, to someone who was already eating, if you like, sufficient carbohydrate, can you generate more brain energy? Can you get any benefit in that way?
Not sure I understand the question, Patrick. Are you talking about modifying the diet so as to? No, go
Well,
ahead.
yeah, it's sort of an either or. I mean, if we sort of take the first, part of this is where do we make ketones from in our diet? You mentioned the medium chain triglycerides that occur in the breast milk, but where do we make ketones from in our diet?
Okay, so in the infant's in a special situation because unless you take a supplement of medium chain triglycerides as an adult, we basically don't have medium chain triglycerides in our food supply unless you take such a supplement. So the infant is special because it's getting medium chain triglyceride as part of its diet, as it were, from the breast milk. Medium chain triglycerides are not the only type of fat. You do need fat to make ketones, fatty acids. You can make ketones from long chain fatty acids, and you can make them from medium chain fatty acids. So long chain are 14, the definition varies a bit, but 14 or 16 carbons and longer. Medium chain are 6 carbons to 14 carbons. And short chain fatty acids, which are also produced in the body, in the gut, for instance, by the microbiome, short chain are 1, 2, 3, 4, 5 carbons long. All of them can produce ketones under the right circumstances. The most ketogenic fatty acids are, in fact, as far as we know, is butyric acid, which is a 4-carbon fatty acid. It's not in our food supply, but it's produced by our microbiome in the gut when we digest fiber. So short chain fatty acids become an important source of ketones, perhaps just for the gut, but maybe they can circulate as well. Then there's the medium chain, which, as I said, are not in our food supply unless we intentionally take a supplement of them. And there are the long chains. So if you and I, as adults, want to produce ketones and we're not taking medium chain triglyceride, we need to reduce carbohydrate intake. And we need to do that because insulin controls whether fatty acids are going to be burned or whether glucose is going to be burned. And you need to burn the fatty acid, which is a long chain of, as I said, of 16 or usually 16, 18 carbons, like in our vegetable oils. Insulin will control whether it is the fatty acid that's being burned. Unless you burn the fatty acid, you can't make ketones. So insulin is really the deciding hormone that controls that process.
Right.
And so if you're going to make it on our typical diet without MCT, you have to reduce insulin. And to do that, you have to reduce carbohydrate. And then you and I can generate ketones gradually and can generate a fair amount of ketones. The brain can run practically 80% of its fuel can be ketones in adults who are on a ketogenic diet. So extremely low carbohydrate intake.
So olive oil, for example, that's a long chain fatty acid, isn't it?
Yeah.
And something like coconut oil, palm oil, that contains a fair amount of medium chain triglycerides. Is that correct?
I'm not sure about palm oil, but coconut oil contains 6 to 8% medium chain triglyceride. You need to be careful because the medium chain triglyceride, as I said, was 6 to 14 carbons. Mm-hmm. 6 carbon is definitely ketogenic. 8 carbons, it's usually in pairs. So we basically don't have the odd numbers amongst fatty acids. So it's 6, 8, 10, 12, 14. 6 is ketogenic. 8 is very ketogenic. 10 is less ketogenic. And C12 and C14 fatty acids are essentially not ketogenic. And they are the predominant, they're still called MCT. So it's a bit confusing for people. All MCT are not necessarily ketogenic. You have to have the 6, 8, and 10s. And coconut oil is predominantly C12 and C14 for the MCT. So you can call coconut oil an MCT, but it's mostly not ketogenic.
Yes, I think 7% of it is C8 or something.
Right, something on that order. So it's. I'm not saying it's not beneficial. I'm not saying the C12 and C14 could not be important for the brain, but they're not ketogenic fatty acids. So there's a little bit of confusion. It's pretty hard to That's just one needs to know a little bit more. And when one goes to a store, a health food shop to buy MCT, for instance, or on the internet, one has to try and do a background check to make sure that one's getting an MCT with C8 and C10. Otherwise, it won't be ketogenic.
So I know in your research you've used C8 and C10 oil. I take a tablespoon of C8 oil every day. I think the important point you're making is that insulin is like the switch. So are you saying that basically if a person is consuming a fair amount of carbohydrates, and especially refined carbohydrates, sugar and so on, and then chose to have, for example, a tablespoon or two of C8 oil, they may well not use it because you've got to get that insulin switch turned off to transfer to the ketone production.
Well, actually, that's not quite correct, Patrick, and I'll tell you why. The medium chain fatty acids, the C8 and C10 that are ketogenic, do not depend on insulin, are not affected by insulin to be metabolized, to be burned by the liver and then produce ketones. It's the long chain fatty acids that are affected. Right. So you can be on a sort of a high carbohydrate intake, take your MCT oil, and you will still produce ketones. If however, you're not on the MCT, there's no way the olive oil that you're taking as a vegetable, as a salad dressing, for instance, it's not going to be ketogenic because the insulin is going to be blocking the utilization of the long chain fatty acids in olive oil and will not permit production of ketones. So MCT bypass the insulin blockade, and we've actually looked at this in pre-diabetic women that are sort of on their way to diabetes, and we can see a close to normal ketogenic response from MCT despite the presence of elevated insulin, mildly elevated insulin, but still elevated. So the MCT do have a sort of a backdoor entrance to producing ketones that does work.
And when you say MCT here, are you talking about C8, C10? Or are you talking?
Yes, specifically C8 and C10.
Okay.
We call it ketogenic MCT as a distinction of sort of general MCT.
So in your studies, which I'd like to get onto with people with cognitive decline, do you change their diet as such, or do you leave the diet the same and just give the ketogenic C8, C10 MCT?
No, we did not change their diet, at least not intentionally. We had a fairly rigorous protocol of imaging and cognitive tests and blood samples and so on. So we said, they're simply not going to comply if we say you've got to reduce your pasta and bread and rice and potato intake as well, your carbohydrate intake. So we said, we know that the ketogenic effect exists on a typical Western diet. Let's just try and keep this as simple as possible. So we did not intentionally reduce their carbohydrate intake. That could be done, and it would possibly be more effective. But in the end, what you want is to have people that are able to complete a 6-month study, which is a fairly long period of time. And so we tried to minimize the demands on their energy and their ability to comply.
And what happened to their brain's production of energy?
Well, it's the brain's utilization, which we were able to measure. So the MCT are definitely producing ketones. Remember that MCT are absorbed fairly quickly, so that if you take a teaspoon, as you do, of MCT at time 0, within 3 hours of taking the MCT, the ketones will have gone up, but they'll be back down to baseline. Mm-hmm. So it's a transient effect, and that's the disadvantage of trying to produce your ketones from MCT or from a ketogenic salt or a ketone ester that could be bought on the internet. It's a short-term effect, and you need to keep taking the supplement twice a day, 3 times a day, 4 times a day even, in order to maintain the ketone levels. So that's a challenge, but the brain will use them when they're available. The brain likes ketones. In fact, our studies and some other studies show that in preference, when the brain has sees both ketones and glucose, it will use ketones in preference to glucose. And it will, if it has lots of ketones available, it will suppress glucose uptake because it's got enough energy coming in already. So ketones are important to the brain and it likes them.
And in your studies, did people end up producing more energy from glucose, ketones? What happened to the utilization of the ketones and the glucose? Did glucose go down when you supplied ketones?
No, so glucose, if you're a healthy adult with normal brain glucose uptake, then when you take a ketogenic supplement or a ketogenic diet, it will suppress brain glucose uptake. That's in healthy normals. We were looking at people at the beginning of Alzheimer's disease. They have about a 10% deficit in brain glucose uptake. So when we gave the MCT supplement, we saw an increase in ketone utilization by the brain. It did not push the glucose uptake down because we think it's because there was already a deficit. So it's not like as if the glucose was supplying all the brain's energy needs. There was what we call a brain energy gap. We think of the what they say on the London subway, which is mind the gap, and I've got a couple of stickers of the mind the gap around the office because that's exactly what we're trying to do. There's a gap in glucose uptake as you get older, so the ketones help fill that gap. We haven't been able to give enough MCT to overfill the gap and push glucose uptake down. So that's not easy to do because MCT tend to have cause some stomach upset if you take a high dose. So at the moment, we've partially been able to partially correct the brain energy deficit at the beginning of Alzheimer's disease, the problem with glucose, but we haven't been able to completely correct it with the MCT and ketones.
And I think the energy from ketones went up by over 200%. Is that correct?
The amount that goes in, yes, it went up by over 200%, so doubled. There was still a gap, an energy gap in the brain, but we had partially corrected that. We didn't know when we started how much of that gap we were going. We knew the gap existed, but we didn't know how much we were going to correct that gap when we started with a 30-gram dose, which is like a large tablespoonful per day. So we were successful in partially correcting that gap, but not completely.
And clinically or experientially, how would somebody, how would someone feel cognitively with that energy gap? And what happened when you helped partially fill it by providing these MCT oils?
So some people were convinced they were on the MCT and were feeling better, but they weren't. They were double blind, so they didn't know, and we, the team, didn't know which they were on. We had a sort of an independent control of which supplement, placebo or active, that they were on, and some people on the placebo had the impression they were doing much better. So that's an important reason for having a placebo. Just taking care of people and being interested in their lives and taking blood samples and then participating in a research project helps them feel like things are going better. So experientially, as you say, there was no difference. And this is what's called mild cognitive impairment. It's the very beginning of Alzheimer's disease. People do not have significant memory loss. Their activities of daily living are essentially normal. So we did not expect a dramatic effect, and we didn't see a dramatic effect. But there was nevertheless a benefit in all the 5 major cognitive domains. So their episodic memory went up, their problem solving went up, their language went up, their attention, and the speed at which they process information. So those are the 5 main cognitive domains, and they all improved statistically. And directly in relationship to the entry of ketones into the brain, because we were doing the brain ketone imaging on them the same day as they were doing the cognitive tests. So we could see that relationship existed. And ideally, we would have raised ketones a bit more. We would have corrected the energy gap a bit more, and we possibly would have had a better effect on cognition. But that's what we've learned. We didn't know all that when we started.
So when you say increasing the ketone energy a bit more, if you were to, redo that experiment or run another experiment, would you increase the amount of MCT, and would you go for the C8 or the C10? What do you think might be the optimal for somebody in this brain energy gap, mild cognitive impairment zone?
Right. Well, we didn't know that C8 was more ketogenic than C10 when we started. You'd say, well, why didn't you check that first? It's something we never even anticipated. So we learned that on the way. And so, yes, we would use C8 instead of C8 and C10 because C8 gram for gram is more ketogenic than C10 by probably 15 to 20%. We would probably use C6 if we could get it. C4 is even better, but C4 is an absolutely revolting smell, butyric acid. So it's really a non-starter. And we would, so the MCT 30 grams a day. Why only give 30 grams? Well, as I mentioned, it does cause stomach upset, can cause diarrhea. So we tried to use the dose. We used the dose that we thought would probably be the best tolerated. Because if you give people diarrhea, they're going to drop out of the study. So that's a non-starter. So 30 grams was what we sort of estimated, and that's where we started. But in retrospect, we can see that if we could give twice as much, we probably would come much closer to correcting the brain energy gap. So 60 to 70 grams of MCT per day. There are very few people that can take that dose. You could divide it up into 7-10 gram doses over during the day, but that's way too many. You have to be extremely disciplined to do anything sort of 7 times a day for a research project, whatever it is. So you've got to try and keep it as simple as possible. And the obvious way around it is to give a ketogenic supplement that is more ketogenic than MCT. Those didn't exist at the time. I started this project in 2015. There were no ketogenic salts and no ketone esters on the market at the time, so there wasn't an option. It was MCT or ketogenic diet, and I thought ethically we had a better chance of completing the project and getting it approved to start with the MCT. So things have changed since 2015, and there are ketogenic salts that are gram for gram more ketogenic than MCT. They also contain sodium and magnesium. Sodium might be affecting blood pressure. Magnesium is also has a tendency to increase gut motility, as they say, so a tendency towards diarrhea. So you don't get a free pass with the ketone salts. And they have been contaminated by an inactive form of the ketone beta hydroxybutyrate until recently. So that wasn't a choice at the time, and it's possibly a choice now. The ketone esters are extremely bitter and extremely expensive. So and no placebo.
Yeah,
and no placebo. Sorry.
This is Professor Kieran Clark. Here in the UK, was doing a lot of work on ketone esters.
Yes, I've met Karen and I admire the work she's been doing. But if she's, the issue with the ketone ester is that if you're going to do cognitive studies, as I mentioned, we had people thinking they were on the active form. So the subjective impression by the person and by the team is a critical factor that you have to correct for, you have to avoid. And the only way to do it is to have a placebo treatment. And to my knowledge, the ketone esters still do not have a placebo. So it's very hard to do this type of research without a placebo.
And I think they're being used a lot by extreme athletes as well, cyclists, for example.
Yeah, Tour de France and so on. And I doubt we'll ever know exactly who's on what because it's obviously not proprietary, but you don't want to share with the competition what's helping you ride faster. So a lot of that is never going to be published. And what we need to do is encourage research in this area that is open and available to the public and to other scientists so that we can move the field forward.
And as you say, they are available, ketone esters and keto salts. They tend to be quite expensive and also do taste rather disgusting. But if you can tolerate it, would you say 3 tablespoons of a C8 oil would be a good place to provide your brain with ketones?
I think yes, definitely. And I wouldn't take it in a tablespoon. I think you said you did, but I mean, you can mix it. You can emulsify it.
Mhm.
which I think has two important effects. Well, maybe three. It should improve the taste if you put it into some kind of drink that you like. It might not be orange juice, which has lots of glucose in it, but it could be a milk-based drink, or it could be an emulsion that you can concoct.
Mhm.
So it should improve the taste. Emulsification will improve the absorption. So we know that will improve the ketogenic effect, because you get more MCT that actually gets into the body and into the liver to make those ketones.
Mhm.
And by the same effect, it reduces what goes down the gut, and therefore intends to increase gut motility and increase the risk of diarrhea. So it's definitely an advantage to take it in an emulsified form, in a drink or in a yogurt, or in some kind of form that makes it more palatable and better absorbed.
And this brain gap, is it largely a function of insulin resistance? In other words, a messing up of the insulin signaling into the brain cells?
That's tough to answer, Patrick. I can't give you a definitive answer. I don't think we know. The the one important point to make is that glucose is pulled into the brain, which means that it's the brain cells that are active that are deciding how much glucose they need, and they then tell the sort of the biochemistry of the brain to give us more glucose, and the transporters that are activated, the doorway from the blood vessels in the brain to the brain cells, the glucose transporter is there, and they will open up and draw glucose in relation to this, to the utilization of glucose. So it's driven by the brain's activity. That it's completely the opposite with ketones. Ketones are pushed into the brain. We call it push and pull. So glucose is pulled into the brain in relation to brain cell needs for energy, and the energy currency called ATP. But ketones are pushed into the brain. So as soon as they're present in the blood, they are found in the brain, and they're used by the brain, and it's called a straight line direct relationship. So why is the glucose gap there? There's something going wrong, obviously, with glucose utilization in the brain. Are the cells somehow not working very well, and they're not able to sort of send the signal, we need more glucose, and so they're not getting more glucose? You can bombard the brain with glucose. You can eat ice cream all day, and it's not going to increase the way the brain uses glucose. In fact, it's going to cause problems, as you can imagine, with insulin resistance. We don't know if insulin resistance is driving the problem at the start of Alzheimer's disease. It's part of the problem, but I don't think anyone has any good tools to measure insulin resistance in the brain in humans, to assess, to what extent that problem is present. And if you can correct type 2 diabetes in people by going on a low carb diet. And so you can eliminate the insulin resistance that's measurable in blood. Is that the same degree of insulin resistance as in the brain? Is the brain's insulin resistance actually changing when you correct type 2 diabetes in people? One of the leading experts on this is in the UK. I think he's in London, David Unwin, who I'm sure you know, Patrick.
Mhm.
He's one of the first people to have shown that you can correct type 2 diabetes. And he may know whether you can actually change insulin resistance in the brain, but I don't know if that's possible. So I'm not sure how to change the brain's problem metabolizing glucose. We thought exercise would help. It doesn't really change it. In someone who's got a problem, a brain energy gap, a brain glucose gap, exercise doesn't seem to change that, but it does change the way the brain uses ketones. So at least we have, as you say, a hybrid car, which is actually an analogy I've been making for some time, and I didn't realize that you've written a book about it, Patrick. Congratulations! I've got to go get that. But
I'll
it
send
is a hybrid car. Pardon?
I'll send you a copy, The Hybrid Diet.
Oh, that's so kind. But it is a hybrid car, and so you can bypass the problems with the petrol system and the petrol engine by using the electrical system, the battery, and the electric motor. And that's the beauty of the way the brain is set up in our evolution.
Now, moving to sort of middle age, I'm 65, 40, 50, 65, not having a brain gap as such, not having insulin resistance as such. In order to really start to produce more energy from ketones as opposed to glucose, in that sort of healthier situation, is it essential to therefore reduce carbohydrates, not just increase, for example, C8?
Yes, I think you need to take more than one approach. There's no magic in MCT. They can go so far, but I don't know whether I don't think they're not going to improve insulin resistance.
Mm-hmm.
Um, you mentioned sort of started out your point by mentioning at 40, 50 years old, but probably not. No, I think the intention was to say that there's probably no brain energy gap or no brain glucose gap at that stage. But I'd like to actually correct that impression. If that may, perhaps that's not what you said, but that's I think what I heard. And what's really important is that we see a problem with the brain energy gap in 20-year-olds.
Mm-hmm.
And it may even be lower than that, who have insulin resistance. So the brain energy gap for glucose is not a function of age. It's more common in older people because older people have more a tendency to have poor control of glucose and a creeping form of insulin resistance. But it can start much younger. If you've got type 2 diabetes as a young adult, which is not at all rare, as I'm sure you know, our evidence in a small study suggests that you've already got a brain energy gap with glucose specifically. So this problem is an insulin resistance dependent problem. It's not an age phenomenon specifically. And it is correctable. It's entirely correctable by reducing carbohydrates. Would it be better to have MCT at the same time? It would certainly help because correcting type 2 diabetes is not something that will happen overnight. It's not like taking an antibiotic for a serious infection. It's probably, if it took 10 years to become type 2 diabetic, it's probably going to take 10 years to get back to normal. So you could accelerate the process and reduce the brain energy gap by taking MCT, even if you're 30 years old and have type 2 diabetes. But the MCT are not going to correct your type 2 diabetes. So the reduction of carbohydrate is still an essential component. If you don't have type 2 diabetes, you can still use a lower carb intake and MCT preventively. It's going to make the brain stronger. So it's a win-win situation. Prevention or primary prevention or secondary prevention, both will require the same path: produce more ketones and reduce insulin resistance.
Now, I know this is not your specific area of research, but there's more and more research coming out on other neurological and mental health conditions. I'm thinking Parkinson's, epilepsy, schizophrenia, even depression. Some using low carb, high fat, ketogenic diets. I'm not sure how many have actually explored, for example, MCTs. And I'm not sure if there are any that have done both together. But what are you seeing in terms of the application of a more ketogenic approach in relation to other mental health issues and neurodegenerative issues?
Well, the work in Alzheimer's disease has kind of led the way. Apart from, I mean, as a neurodegenerative problem, epilepsy is actually where it all started, as you probably know, with a ketogenic diet. But in the sort of past 20 years, it's in Alzheimer's disease that this work started, and it's because the brain energy gap with glucose was best defined, was most clearly, I should say, defined in Alzheimer's disease. So it's well ahead of what's being done in other neurodegenerative disorders. Having said that, there's a study from 2005, I think, in a very small cohort of 5 or 6 people. It was published with a ketogenic diet in Parkinson's disease, with some benefit for the neuromotor problems. That was essentially forgotten about, and was again repeated around 2018 in New Zealand with Matthew Phillips, 2018 or 19, something like that. We've picked up on that and our a certain degree of success with our work with the beginning of Alzheimer's disease and moderately advanced Alzheimer's to combine it with exercise. As I mentioned a moment ago, exercise does improve ketone uptake. So we said, well, to get a bigger bang for the buck, maybe we should combine exercise with a ketogenic supplement. And we're using a ketogenic salt because it's more ketogenic than MCT. We're expecting to analyze the first results of three patients before the end of the summer. And by this fall, we should have 6 or 7 that will have completed, and we'll see. So it's only starting that work. Other people are starting to get interested as well. Again, a placebo is going to be critical, and there hasn't been one available. So it's starting, Patrick, and it's growing. It takes funding. It takes the right supplements. It takes people with researchers that have an interest, and all of that is moving forward. 10 years ago, I think it would have been practically unthinkable. So I'm impressed with the progress that's occurring, but it never seems to occur fast enough.
Yeah, I'm thinking of, I'm sure you know Albert Denane. Is it Denane? Or Danian, who's...
Danan,
Yeah.
I think in Toulouse.
Yeah. And he's been reporting very good results, I think, not placebo-controlled trials, but trials with people with depression and schizophrenia and bipolar.
Yes, I didn't address that point, but yes, I think his is a critical observation. And so it's not a defined study, it's not a controlled study, but he said, look, I've got a psychiatric ward, and I'm not sure how he got the impression that the ketogenic diet could be beneficial, but he was able to reduce carbohydrate intake in a significant number of them. Some were more adherent to the protocol than others, and those that were most adherent, reduced their carbs the most, had the best effect. I think there were 30 some people. So that's where it starts. But there are there's an interest in what's called metabolic psychiatry, which is applying the idea of improving metabolic regulation, improving your glucose metabolism, and trying to basically improve mental health by metabolic health. It's an area that is crying out for better treatments because tragically, many of the antipsychotic drugs actually cause a deterioration in metabolic health. So you fall into this this vicious cycle, I should say, whereby you need to take what's available, but that's actually in the long term is not helping your prognosis. And so this is an area that really needs support, and we're very interested to work with an emerging network of clinics. There are about a dozen metabolic psychiatry clinics around the world now, in the UK, continental Europe, US, Australia, and one in Toronto in Canada, and perhaps do some of the imaging work that we do. Sherbrooke is a small city, so setting up a clinic like that is not going to be easy here in Sherbrooke. But we need to use those tools to see what is the metabolic status of the brain in someone who's got severe depression or first episode psychosis. What's happening to glucose? We don't know. So we don't know if there is truly a glucose gap, and we don't know whether the brain can use ketones in that situation. It looks like ketones are beneficial from Albert Danane's work and from some other anecdotal reports. Chris Palmer, for instance, at Harvard, has published 2 case reports showing that schizophrenics benefited enormously from a ketogenic diet, and they were taking the diet to lose weight, and both said, you know what, life is so much better now, and so it was one of these serendipitous type of observations, in fact. So we need to give this a more rigorous background and basis from which to do more rigorous studies, and hopefully we can make progress in this field too.
Yeah, I'm just reading Chris Palmer's excellent book, Brain Energy, at the moment, which explores this. A couple
Yeah.
of questions in and around this. I've also heard a conversation about ketones and how they could help to possibly reduce anxiety by promoting GABA. While a high sugar diet, it appears, may actually promote uh, glutamates that actually have the opposite effect and increase anxiety. So just going a little bit closer up on ketones and GABA. Can you say anything about that?
It's an area that I'm hoping to start a project in with some colleagues in Denmark, actually, who have facilities that would allow us to study brain GABA and brain ketones simultaneously. So that takes some very specialized imaging equipment, and they're equipped, and we've talked about it, and we're starting to set up the protocol to get approval to do that sort of study. So it's on my radar. It's been thought about and talked about for 20 or maybe 30 years as part of the reason that a ketogenic diet is beneficial in epilepsy, because GABA is called an inhibitory neurotransmitter, which means it helps calm down to overexcitable brain cells. And the overexcitement is usually caused by glutamate, which is an excitatory neurotransmitter. So, as you say, does the same thing apply in anxiety? We're wondering whether it applies in Alzheimer's as well. Ketones do not, the carbon from a ketone molecule, ketones have 4 carbons, and they can be used to make brain energy. They can't be used to make GABA. So if GABA goes up, it must be by some indirect mechanism, and you can't flood the brain with glucose, and glucose carbon can be used to make GABA, but it seems like that process isn't working because the GABA level seems to be a bit lower than they should be, at least in epilepsy and possibly in anxiety and other conditions. So if you provide the ketones to the brain, does that in fact liberate some of the glucose that is going into the brain? Because even on a ketogenic diet, there's still glucose getting into the brain. And even in severe Alzheimer's disease, when the glucose uptake is seriously blocked, it's still about 50% of what should be getting in is getting in. So it's not like there's no glucose available. And maybe ketones allow some of the glucose that would be going to make fuel to go to do other things, like making GABA. So that needs exploring. I think even if we don't know whether it works through GABA, if we can show convincingly that ketones or a ketogenic diet is beneficial for the treatment of anxiety, that's a big step forward in the personal lives of millions of people.
Yeah, for those who don't know, GABA is both an amino acid and a neurotransmitter, which has the effect of sort of cutting the adrenaline switch. So a lot of Valiums, Libriums, benzodiazepines, non-benzodiazepines as well, they're all working on that GABA pathway. And one thing that always intrigued me very much working in the area of addiction and brain chemistry and nutrition is that it is said that GABA doesn't cross into the blood-brain barrier. However, if you supplement a gram, 1,000 milligram of GABA, it has an immediate, very, very calming effect. So it's doing something. GABA is one of those nutrients in my toolkit that I've found very, very useful for people with certain.
Well, I think GABA is metabolized and perhaps even produced in the gut as well. And perhaps there's a connection through the vagus nerve or through perhaps some hormones. So it may not be getting into the brain. I don't know. And that's something we should be able to test with imaging techniques, but I'm not sure. I haven't given it enough thought. But there could be some indirect effects. It doesn't necessarily have to get into the brain because, 1,000 milligrams sounds like a fair amount, quite a whack, actually.
The other nutrient I don't know if you've come around the edges of is chromium, the mineral chromium.
Well, I know that chromium is reportedly involved in improving glucose tolerance.
Mm-hmm.
That's the only connection, and maybe pancreatic function. I'm not sure. I don't have much experience with it, but I draw a link there. I hope that's correct.
Yeah, I mean, the reason why I even mentioned it was talking about, do we really know how to reverse insulin resistance, improve that glucose supply in the brain later on, and chromium supplementation at quite a high dose, usually 600 microgram, it's probably 10 times more than we need normally, does seem to do all the right things. That is, lowering HbA1c, the glycosylated hemoglobin, seemingly improving insulin resistance, but we don't know in the brain. And I'll tell you a story that you might like, but it came from a professor of psychoanalysis at Chapel Hill in, is that North or South Carolina? And he had a patient that he'd been psychoanalyzing for years who was depressed. And one day the patient said to him, "I've taken these pills from the health food shop and I'm better." And the professor of psychoanalysis, I think there were four different ingredients in the pill. So he kind of placeboed the thing. He gave his patient a different envelope every week and said, "Take these." And it turned out it was the chromium. So what he then did was to design a placebo-controlled randomized trial giving chromium or placebo. And this was very specifically to patients with what's called atypical depression. And atypical depression seems to affect younger people who sleep a lot, feel groggy a lot, crave carbohydrates and certain attributes, which actually it seems to be the predominant number of people with depression have atypical depression these days. And it was incredibly effective. I think 60% of people in the study had complete remission from their depression. And the interesting thing was that the effect of chromium was, literally within 3 or 4 days. It's a very, very quick effect. So there was something going on with chromium, insulin resistance, serotonin, and mood, which I've never quite found anyone to fully unravel. I just thought I would mention that.
Well, that sounds interesting. Maybe we can follow up offline as to the source of that information. I'd be interested to read up on it.
Yeah, I'll certainly send you the papers. So here we are coming towards the end of our podcast. And I always like to ask eminent scientists like you who are very much involved in this, what you do for yourself. Because here you are, you've got the research, the areas that may not be proven yet, but are certainly looking positive. Do you eat meat? Do you eat fish? Do you eat, do you control your carbohydrates? Do you have MCT oils yourself? Maybe omega-3, something we haven't mentioned, we certainly could have spoken about. What's your strategy for optimizing your own brain health?
Well, I'm moderately proactive about my diet. I'm not fanatical about it. So I do eat carbohydrate. I don't know what percentage of my energy intake is carbohydrate, but it's relatively low in the easily absorbed carbs. And I think one thing we should mention is that, like with fats, all carbs are not the same. A bowl of oats, rolled oats, is not the same as the same weight of white bread, for instance. So it's important for people to understand that some carbohydrates are absorbed slowly, and there's nothing wrong with whole grains, even though they're essentially, well, not totally carbohydrate, but carbohydrate rich. It's the question. The question is, how fast are they absorbed? And that's what's going to influence insulin. So I'm fairly prudent with sweet foods and with desserts. My insulin is okay. My blood pressure is okay. I'm moderately active in terms of sports, a bit of tennis and golf and cycling and cross country skiing, but not in a regimented way. So I've lost weight from my 20s, and I'm now 70. Gradually, not intentionally, but I haven't gained weight as I've gotten older. And so I think the main measures of my metabolic health all suggest that it's pretty good. I was actually involved in one of my own projects with continuous glucose monitoring, so I was able to see on my typical diet, my glucoses were kicking around 5.8 to or so at baseline. So that's excellent, and I haven't done anything really dramatic. I do eat fish and meat. Not a lot, but I do. And so I guess I've got my bases covered. I like a little bit of brewer's yeast in my salad too, which helps perhaps uh, cover for perhaps a suboptimal fruit intake. I'm just not much of a fruit intake eater, and I'm probably not quite as much veggies as I should either. So I try to patch it over with a little bit of brewer's yeast now and again. But so far so good. I mean, who knows what I might get struck by tomorrow or next week, but
And
so far it seems to be okay.
do you take any MCT oils, any
Oh,
C8?
sorry. Yeah,
Yeah.
I don't take MCTs per se. I get a sort of a very transient, rapid headache from it, but I do consume probably 750 grams of coconut oil per month, roughly a jar of coconut oil. So it's relatively solid. It's like a butter, and I'll put it on a sort of a whole bread toast, a nice rustic type of artisan bread. As a kind of a butter, and that's basically what I use. So, and I'm not afraid of butter either, by the way. So it's, but I do consume some coconut oil and not much MCT.
And what about omega-3? Do you supplement omega-3? I'd be interested to know.
No, not specifically, but a moderate amount of fish intake.
Mm.
The lab used to always complain if I wanted to be involved in a project because they said you're always an outlier. Your fasting ketones are always higher. Your fasting omega-3s are always higher than the other people in this study. So we don't want you involved. So I don't know exactly what explains that, but I guess the main markers are fairly positive in my case.
Thank you very much, both for your excellent, many decades of research, and I'm looking forward to hearing about all your new studies as they unfold. Is there anything else you'd like to say to our listeners on this subject of ketones and the brain?
Well, Patrick, I think it's an important service that you're doing to them, for them to invite people to come and talk about this, and I hope it informs them. Sometimes people like me in our field say, it's moving forward so slowly, and in some ways, the internet allows us to bypass the whole scientific community, where there's a certain amount of resistance and a certain amount of dogma, around Alzheimer's disease and how to treat it and how to treat depression and so on. And the idea that you can actually correct type 2 diabetes, it's still going to take the scientific community a long time to understand. So in the meantime, the public, I think, can take what it wants. Your listeners can take what they want from this podcast. And if they're willing to reduce their carbs a little bit, it's not going to cause any serious problems. It takes a bit of discipline to start, but you can do it, and you can drop your sugar from the coffee and from tea, and perhaps have one biscuit instead of two at tea and whatever. And slowly you find, what, I don't want it. I don't need as much marmalade on my toast, and you will adapt, because we have an addiction to sugar, and it's pretty harmful, and it's a long-term process. So getting started a little younger is going to help. You can do it.
Professor Stephen Cunnane, thank you very much for sharing your time and sharing your wisdom with us. All the best.
It's been a pleasure, Patrick. Thank you as well. Thanks.